hybrid navigation based on GPS data and SIFT-based place recognition using biologically inspired SLAM. And my name is Sahar Salimpour. The overall structure of this presentation is, first of all, the goal of our research, then the summary of this research and our methods for visual matching and place recognition parts of the RAT-SLAM, then creating a new environment in desired platform, robotic platforms, and a navigation method based on visual data and GPS information, and finally the results of our proposed method and the conclusion part. Our goal during this research was improving a RAT-SLAM, which is a bio-inspired system based on SLAM for place recognition in indoor environment, and defining a predetermined path for robot navigation based on our proposed method for place recognition part. And also we have created a new environment in order to navigate and route the robot based on our method and GPS data in a new environment in VBots and matched to the MATLAB. RAT-SLAM is a type of SLAM that means simultaneously localization and mapping system, which is inspired by the hippocampus of rodents. RAT-SLAM system actually consists of different components and parts, such as post cell, local view cell, visual odometry, and finally the experience map as the results. In this research, our main goal and responsibility was working on place recognition part, which is a visual system based on finding the similarity between images. In a RAT-SLAM algorithm, which is proposed by Dr. Milford, the similarity between images was based on the sum of absolute intensity differences between images called SAD algorithm. But nowadays we know that there are so many different methods for visual matching and finding visual features among images, like SIFT, which is scale invariant feature transform. This method is a visual processing algorithm and highly invariant to different concepts like rotation, scaling, lighting, and so many other features that we are not dealing with in our project. But SIFT is a very popular method and very simple method for visual matching. As I mentioned, our goal during this research was improving the visual matching part of RAT-SLAM system. In this regard, we proposed a two-steps algorithm for place recognition. First of all, as the basic RAT-SLAM system, the images are compared with the SAD value, I mean the sum of absolute differences between two images, And in the next step, we used SIFT for feature extracting and saving these features as the output vectors in local view cell. Actually, these two steps was because of the SIFT algorithm, which is a computationally demanding algorithm. And if we wanted to use just SAD, this method actually takes a lot of time. So in order to reduce the computational time, we proposed these two step algorithm, which is first of all using SAD, and then as the second part we use SIFT. In the next step, I want to explain about a new environment that we created in VBoats for testing our proposed method based on the MATLAB version of RATSLAM, which called OpenRATSLAM. In VBoats, we create a new environment which is like an indoor environment using some walls with different textures and some objects in indoor environment, and a robot, a differential wheel robot using forward-facing camera moves within this environment and record an online video, and this online video is sent to the MATLAB in order to process by the RATSLAM. Another novelty in our research is a visual navigation based on GPS data and post-cell data, which is completely depends on visual odometry data and local view cell module. Actually, in post-cell odometry, the robot head direction is called theta, which is completely obtained from the visual odometry and local view cell in order to localize robot and its head direction and X and Y information. In this method, we define a new path by some successive target points using GPS. Actually, we save these points, these GPS data of these points in a module called GPS module, and in each step, robot head direction tries to be in direction of this GPS file by using this formula, which is we used for finding and calculating the theta between the target points and a robot. When we find this direction, a robot turns until its head direction was become equal to these GPS theta. In this section, I will talk about the results that we obtained from this algorithm. Actually, improve the RATSLAM, which we propose based on the SIFT and SAD, takes up fewer memory cells and can be used for a large scale to save more frames and more visual templates. And also, it's more accurate in detection of revisited place, so it's faster. And also, our proposed method had more true positive recalls in the revisited places. It means that when robots faced a new revisited places, our algorithm is more faster and more accurate than rat slam. Another thing is loop closure detection. It means that when a robot can determine a revisited place and match it with the post-sale information in order to match the XY information of its localization, then loop closure creates. In our proposed rat slam, which is called improved rat slam during this research, has more loop closure detection because of the more revisited places, detection of revisited places. And finally, when the results came to experience map, we can see that our proposed method, which is in red, is more accurate than the blue map, which is created by the basic rat slam. The second part of our proposed method was the navigation method, which was based on the GPS and postal information. As can be seen from this image, from this video that I will play it, the direction of the robot was updated based on the proposed method. It means that when a robot moves to the target points, it turns correctly to the another point which we predetermined in GPS module as the determined path. As we can see, the robot moves correctly in these determined paths. In order to compare our method to a basic rat slam, we use another dataset rather than our proposed dataset. This dataset called IRAT 2011 Australia dataset. As we can see, activity in view cell for our proposed rat slam by SIFT method is more than the recall point is more than the blue line, which is for basic rat slam. And also our method, as we can see, use just about 100 local view cell rather than 500 local view cell in basic rat slam. So because of this, we can say that our proposed method can be used for a large data set, and it is faster. It has more recall points in yellow boxes. We can see that the red points and the red lines is more than blue points. In this table, it's the comparison of visual processing time. In our proposed method, the processing time in first frames sometimes is more than total time in rat slam, but in larger number of frames, we can see that our proposed is more better than rat slam in total time. In the conclusion, actually, the proposed algorithm which we used was SAD and SIFT algorithm for matching visual templates. This algorithm is completely robust to the change in images. Our proposed algorithm had more recall, so it has better recall and precision rates in comparison with the basic RATSLAM. As we seen, robot in proposed visual navigation method moves in predetermined paths correctly and reach to the target points without any problem. And finally, our proposed method was very faster than basic RATSLAM. It also used less memory cells in visual cell. Thank you for your time.